Here we're going to talk about oxidation numbers, the formation of ions, and the electron configurations that accompany that. The structure of the periodic table gives us several clues about the way that atoms will gain or lose electrons to form ions. For this type of discussion, we consider only the s block and the p block elements. The electron configuration tells us how many valence electrons there are for each group or family of elements. Group 1 has one valent electron, the s1. Group 2 have two valent electrons because they have two electrons that fill the s orbital. In group 13, or 3a, the first electron in the p suborbital is present. The valence electrons are an accumulation of the electrons for that energy level. So for group 3a, they have both s orbital electrons plus the 1p orbital electron for 3. Progressing across the right of the periodic table, they accumulate. So in the next row there are 4 valence electrons, and then 5, and then 6. The halogens have 7 valent electrons, and then finally the noble gases have 8 valence electrons, the perfect octet. They have a complete s orbital as well as p orbital, s2, p6, for a total of 8 electrons. So as long as you have a periodic table handy, you can figure out how many valence electrons there are for each family of elements. Starting from left to right, considering only the s and p blocks, ignoring the transition metals in the d block, it's continuous 1 through 8. 1, 2, 3, 4, 5, 6, 7, and 8 valence electrons for the noble gases. All atoms want to reach that perfect noble gas state. They want 8 valent electrons. Therefore, they are willing to sacrifice s group electrons or add on more electrons to round out their p orbitals to a complete set. So, if looking at the periodic table and looking at group 1, if I sacrifice that 1 valent electron from S1, the new charge on those atoms is +1 because it's now deficit that 1 negative particle. If it's from the second family, it doesn't take too much energy to give up those 2 valent electrons, and giving up those 2 negative particles leaves the atom with a +2 charge, because now its number of protons are imbalanced with its number of electrons. Jumping over to group 13, or 3a, the 3 valent electrons of that family can also be removed to form a +3 ion. It requires much more energy than it would, say, an alkali metal to remove the 1 electron, but it still could happen. The group with 4 valent electrons are pretty neutral, so in general these do not form ions. The noble gases also do not form ions because they already have the perfect set of 8. They have no need or no motivation to lose or gain any electrons. For the families containing 5, 6, and 7 valent electrons, it would take way too much energy for them to lose those electrons. It would take less energy for them to just go ahead and gain more to complete their set of 8. If a halogen with 7 valent electrons gains an electron, then it now has 1 extra negative electron, and it takes on a -1 charge. The group with 6 valent electrons require 2 more electrons to get to the noble gas state. Therefore, their oxidation number is -2 for the 2 additional negative particle. And then lastly, the group with 5 valent electrons would require 3 more to get to that noble gas state, so their oxidation number is -3. The electron configuration of these ions demonstrates the addition or subtraction of these electrons to become like the noble gas. Fluorine's electron configuration is 1s2, 2s2, 2p5. Its element number 9. It has a total of 9 electrons. Its valent electrons are of the highest energy level, in this case, energy level 2. There are 2 s electrons and 5 p electrons for a total of 7. Fluorine, as a halogen, has 7 valent electrons. If it gains an additional electron, now it has a configuration of 1s2, 2s2, 2p6. And that is the configuration of the noble gas neon. On the other side of the spectrum, lithium from group 1 has the electron configuration of 1s2, 2p1. If it loses its 1 valent electron to become an ion, a cation, now it has a noble gas configuration that matches that of helium. There are a variety of elements that can become ions to reach the electron configuration that matches that of neon, 1s2, 2s2, 2p6. Nitrogen's configuration is 1s2, 2s2, 2p3. It requires 3 additional electrons to reach the noble gas state. Therefore, nitrogen's ion is N to the negative 3 for the additional 3 negative particles. Oxygen is only 2 electrons away from neon. By gaining 2 more electrons to form that octet, oxygen's ion is O to the negative 2. All halogens, including fluorine, have 5 p electrons, 2s2, 2p5 for a total of 7. Only 1 more electron is required to reach that noble gas state. Therefore, fluorine's ion is F to the negative 1. These are the 3 anions that can form to have that neon noble gas electron configuration.
Now let's consider the cations for neon. Sodium's last electron is the 3s1 electron. When sodium loses that last electron to become an ion with noble gas electron configuration, its charge is now Na plus 1 because there's an imbalance of more positive particles than negative particles. Like sodium, magnesium will also lose its valence electrons. Its valence electrons in the highest energy level, level 3, are the 2 valence electrons, giving magnesium a charge of plus 2. The valence electrons that aluminum will give up would be all of the valence electrons from the 3rd energy level, both 3s2 electrons and the 1 3p1 electron, giving aluminum an ion charge of plus 3. To recap, use your periodic table to figure out electron configuration, valence electrons, and even oxidation numbers. Going from left to right, considering only the S and P blocks, sequentially, they have 1 electron for group 1, 2 valence electrons for group 2, 3 valence electrons in group 13, which is also group 3A, 4 valence electrons in group 14, 5 valence electrons in group 15, 6 valence electrons in group 16, 7 valence electrons in group 17, and finally 8 valent electrons, the complete octet, for group 18, the noble gases. The oxidation numbers for the cations depend on the number of valent electrons that they will lose in order to become an ion. Those elements in group 1 will form plus 1 ions when they lose 1 valent electron. The elements in group 2 will have an oxidation number of plus 2 when they form ions for the 2 valent electrons that they lose. And group 13 will have a charge of +3. Remember, group 14 will not form ions because there's no energy difference between gaining 4 and losing 4 electrons. Also, the noble gases do not take on oxidation numbers. They have no motivation to form ions. They have the complete octet of electrons. Okay, group 15 form -3 ions, group 16 -2 ions, and the halogens, group 17, always form -1 electrons. Memorize the pattern. +1, +2, +3, skip 1, -3, -2, 1. Then when you look at a periodic table, you can figure out these oxidation numbers for yourself. Good luck on your test.